Welcome to this lesson on resistance. Resistance is a fundamental concept in electricity that describes how materials oppose the flow of electric current. Think of it like friction in mechanical systems, but for electricity. Understanding resistance is crucial for working with electrical circuits and designing electronic devices. So what exactly is resistance? Resistance is the property of a material that opposes or restricts the flow of electric current through it. Every material has some amount of resistance. We represent resistance with the symbol R, and we measure it in units called ohms, represented by the Greek letter omega. When current tries to flow through a material, resistance is what pushes back against that flow. Resistance isn't a fixed value. It depends on four main factors. First, the material itself matters. Different substances resist current differently. Second, the length of the conductor affects resistance. Third, the cross-sectional area or thickness plays a role. And fourth, temperature influences how much a material resists current. Let's explore each of these factors in detail. The first factor is the material. Different materials have different resistivity, which is their inherent ability to resist electric current. For example, copper has low resistivity, while rubber has extremely high resistivity. The second factor is length. Resistance is directly proportional to the length of the conductor. This means if you double the length of a wire, you double its resistance. The longer the path current has to travel, the more it encounters resistance. The third factor is cross-sectional area. Resistance is inversely proportional to the cross-sectional area of the conductor. This means thicker wires have less resistance because there's more space for current to flow through. If you double the thickness of a wire, you cut its resistance in half. The fourth factor is temperature. In most conductors, higher temperatures increase resistance. This happens because atoms vibrate more at higher temperatures, creating more obstacles for the flowing electrons. We can calculate resistance using a mathematical formula. Resistance equals resistivity multiplied by length, divided by cross-sectional area. Here, R is resistance measured in ohms. The Greek letter rho represents resistivity, measured in ohm meters. L is the length in meters, and A is the cross-sectional area in square meters. This formula shows how all four factors we discussed come together to determine the total resistance of a conductor. Resistance plays a central role in Ohm's law, one of the most important equations in electricity. Ohm's law states that voltage equals current multiplied by resistance. This fundamental relationship tells us how voltage, current, and resistance are connected in electrical circuits. If you know any two of these values, you can always calculate the third. This law is the foundation for analyzing and designing electrical circuits. Based on their resistance, we classify materials into two main categories. Conductors are materials with low resistance that allow current to flow easily. Examples include copper, silver, and aluminum, which is why these metals are commonly used in electrical wiring. On the other hand, insulators are materials with very high resistance that block current flow. Rubber, glass, and plastic are common insulators used to protect us from electrical shocks and to keep current flowing where we want it to go.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.